If you were running out of air in space, your first instinct would probably be to grab an oxygen tank. After all, that's what divers and firefighters do, right? Seems like the obvious solution. But on the International Space Station, relying on tanks is actually a terrible idea. You see, here's the problem. Air is heavy, like really heavy, and steel tanks are even heavier. To keep a crew of 6 astronauts alive for a standard 6-month mission, you would need literal tons of compressed air. And launching that much weight would cost hundreds of millions of dollars, and would take up half the cargo space. If the ISS relied on air deliveries, it would be the most expensive hotel room in the universe. And if a supply ship got delayed, well, guess what? Everyone dies. But we obviously don't want that now, do we? So if the astronauts aren't bringing enough oxygen with them, and they can't even open a window, where exactly is the breath in their lungs coming from? Let's find out. Well, you see, NASA came up with a genius plan. They said, instead of importing oxygen in ISS, we are actually going to manufacture it ourselves. And they are going to do it out of the only thing they have plenty of, and that is water. The secret to breathing in space is understanding what water actually is. We drink it, but chemically, water is just a cage. It's 2 hydrogen atoms trapping a single oxygen atom. This is called electrolysis. By running electricity generated by the station's solar panels through purified water, the station splits the liquid apart. It's basically alchemy. You turn a drink into a breath. The hydrogen is vented into space or used for other chemical tricks we'll get to later. But the oxygen, that gets pumped right into the cabin. It is an incredibly elegant system. As long as the sun is shining on those panels, and as long as you have water, you have infinite air. But I think you spotted the flaw in this plan. If you are turning all your water into air, you are going to run out of water fast. And bringing up water from Earth is just as expensive as bringing up air. So, to make the math work, the ISS has to do something that would make most people on Earth vomit. They have to close the loop. On Earth, the water cycle takes weeks. Rain falls, flows into rivers, gets filtered by the ground, and eventually comes out your tap. On the ISS, that cycle happens in hours. And the source of that water is intimate. The station captures everything. When an astronaut sweats, that humidity is sucked out of the air. When they breathe, the moisture in their lungs is trapped. And yes, when they go to the bathroom, the urine is collected. Because there is no gravity, you can't just let the liquid waste settle. So, the station spins it in a centrifuge, like a salad spinner from hell, to separate the liquid from the gases. It travels through the water recovery system, which heats it, treats it with iodine, and filters it until it is chemically purer than the tap water in your kitchen. Seriously. It's cleaner than what you drink on Earth. As astronaut Don Pettit famously said, "Yesterday's coffee is tomorrow's coffee." Okay, so yes, oxygen is coming in. Problem solved, right? Not quite. Because there's another issue most people don't think about. We are the problem. Humans are biological engines. We inhale oxygen, but what we breathe out is essentially waste gas, carbon dioxide. On Earth, that's not a big deal. The atmosphere and the wind constantly dilute it and carry it away. You never notice it, but put a human inside a sealed metal box, and the rules change completely. The carbon dioxide doesn't drift off. It just hangs there. It builds up around you, forming an invisible bubble of poison right at head level. You don't smell it, you don't see it, you just start feeling off. First comes the headache. Then your thinking gets fuzzy. Decisions get harder, and if nothing changes, your body simply shuts down. Here's the part that sounds counterintuitive. You can't fix this by pumping in more oxygen. That actually makes things worse. The problem isn't a lack of oxygen. It's the buildup of carbon dioxide. So instead of adding more air, you have to remove the waste. That's where the space station does something surprisingly low-tech. It uses a mineral called zeolite. Think of it like a microscopic lobster trap, but for gas molecules. The internal structure of the rock is engineered at just the right scale. Carbon dioxide molecules get caught and held in place, while oxygen molecules are small enough to slip right through. So, every breath you take in space is being silently filtered through a rock that's constantly deciding what gets to stay and what has to be trapped before it kills you. In the early days, the solution was brutally simple. We just dumped the trapped carbon dioxide straight into space. Problem gone. But then NASA realized something uncomfortable. Carbon dioxide isn't just waste. It's made of carbon and oxygen. Every time you vent it, you're literally throwing away half of your oxygen supply. In space, that's not a small loss. That's life leaking out of the system. So they built something smarter. It's called the Sabatier reactor, and it's one of those machines that feels almost unfairly clever. It takes the carbon dioxide you breathe out, the stuff that would normally become dangerous and put you at risk, and combines it with hydrogen that comes from splitting water into oxygen and hydrogen. Both are waste products. Both are problems. Then the reactor forces them to react. The carbon dioxide and hydrogen are burned together in a controlled chemical process. And what comes out the other side isn't poison. It's methane and water. The methane gets dumped. It's not useful on the station, but the water is gold. That water gets fed right back into the system. It can be split again to make oxygen to breathe and hydrogen to reuse in the reactor. In other words, the oxygen you exhale doesn't disappear. It gets captured, recycled, and handed back to you as drinking water and breathable air. Because of this loop, the International Space Station recycles roughly 98% of its water and air. At that point, it's not just a machine keeping people alive. It's a nearly closed ecosystem quietly undoing every breath you take. Just before I get to the next point, if you are enjoying the video so far, subscribe to the channel because we have got some really thought-provoking videos coming up. But this is space, and space does not forgive failure. Machines break, valves stick, software crashes, power goes out. So what happens if the electricity fails and the water splitters stop running? What happens when the oxygen flow just ends? You light a candle, not a wax candle obviously, but close enough that NASA actually calls them candles. Officially, they're SFOGs, solid fuel oxygen generators. And yes, the idea sounds completely insane. When everything goes wrong, when the last thing you want is fire in a sealed spacecraft, the backup plan is to deliberately start a controlled burn. Here's why it works. Inside these canisters is a solid chemical compound that, when ignited, undergoes a reaction that releases enormous amounts of pure oxygen. No electricity, no moving parts, no software. Just chemistry doing exactly what chemistry always does. As the candle burns, oxygen pours out steadily, turning fire into breath. One single SFOG can produce enough oxygen to keep a human alive for roughly 24 hours. Not comfortably, not indefinitely, but long enough to buy time. Time to fix the system, restore power, or survive until rescue. It's the ultimate paradox of space survival. When the most advanced life support systems fail, you fall back on something almost primitive. A slow-burning chemical fire, quietly making air, reminding you that in a high-tech world, the last line of defense is sometimes the simplest thing that cannot crash. So, the next time you see the ISS flying overhead, don't just think of it as a laboratory. Think of it as a mechanical tree. It breathes, it drinks, it cleans itself. And we need to master this. Because if we ever want to go to Mars, there are no resupply ships. We will have to drink our own coffee again and again and again for 3 years straight. Thank you so much for watching. And if you enjoyed the video, make sure to subscribe to the channel and turn on notification for more interesting, thought-provoking videos in the future.